All right, students. So this is the exam 3 review number 6B. So I am looking at the balancing redox reactions chart on the PowerPoint. It tells you exactly step by step how to go through it. So I'm going to go through these exactly. Number 1 says assign oxidation states to determine the element that is oxidized and the element that's reduced. So if I assign oxidation states, oxygen we know is always going to be -2. We have 3 of them, so overall this whole oxygen is going to be -6. Well, we overall have a -2 charge. So we have to make this whole thing equal -2. So what -6 will give us -2? Well, we know that a +4 plus a -6 would give us a -2. So our sulfur is going to be a +4. So we're going to go through and do that for each of them. So once again, this oxygen's -2. We have 4 of them, so we're -8. Overall, we need a -1 charge. So that means this manganese needs to be a +7. Next one, oxygen, still a -2. We have 4 of them, so we're at -8. Overall, we need a -2 charge. So that means that this guy has to be a +6. The last one, this is a +2 charge overall, so it's just also going to be a +2. So let's look first at our sulfur. Our sulfur went from a +4 to a +6. So it changed oxidation states, right? It looks like that it lost some electrons. It looks like it lost 2 electrons, right? So I'm going to write that it lost 2 electrons just so I remember. Losing 2 electrons means that it's oxidation. So the sulfur has been oxidized. Let's look then at, let's see, our oxygen didn't change anywhere, right? That was still a -2. So our only other thing we have is this manganese. So our manganese went from a +7 to a +2. So it looks like it gained electrons, right? Because electrons are negative. It looks like it gained 5 of them. So it gained 5 electrons. So it was reduced. So I did step number 1. Step number 1 was assigning those oxidation states. Step number 2 is writing the half reactions with electrons. So let's write the oxidation reaction. So oxidation, what happened? Our one that was oxidized was our sulfur. So we're going to say SO3 2- yields, right? We're only going to take the sulfur, so our SO3 2- yields our SO4 2-. Okay? So that's what has happened overall. We have had a change, right? We're writing what was oxidized. That is our oxidation reaction. Our reduction reaction, so I'm going to write that a little bit farther down here. So our reduction reaction is going to be our manganese. So our MnO4- yields Mn2+. Okay, so that is what has happened. I have written my 2 half reactions. I did not include electrons here. I could. So what I could do is I know that in this sulfur, 2 electrons were lost. If we lose electrons, those electrons need to be on the right side. So I can add 2 electrons. I know that the manganese, 5 were gained. So I could add 5 to the left side of my reaction. So this is step number 2. This is writing the oxidation and reduction half reactions, and I included my electrons. And I know my number of electrons based on up here, where I figured out how many electrons I had. Step number 3 is balancing by mass. So first you're balancing everything except oxygen and hydrogen. Well, let's look. Up here, the only other thing I have is sulfur. Those are balanced. Down here, my manganese are balanced, right? The only other things I have are oxygen. Okay, so I'm going to do this by the half reaction first. So I'm going to look just at the oxidation reaction, do that whole thing, and then do the reduction one to make it a little easier for us. The next step is anywhere that we need oxygen, we're going to add water. So on the left side, we have 3 oxygens. On the right side, we have 4. So obviously, we need another oxygen on the left side, don't we? So in order to add oxygen, we're going to add a water. So I'm going to add H2O. So I'm going to rewrite my equation where I've added H2O. So I added H2O on the left. The problem is when I added that H2O, I also added 2 hydrogens, didn't I? So now my right side needs to have 2 hydrogens. And that's going to be an H+, are our hydrogens. If we were doing this in a base, we would have to get rid of H+'s and neutralize it with OH. Well, thankfully, this isn't an acid, so we don't need to worry about that. So this should be balanced by mass. That is step number 3. So let me do step number 3 down here. Also balance this guy by mass. So here is my reaction. I have 4 oxygens on the left. I need to add then 4 waters on the right, because I need to get 4 oxygens over here on the right. So now I have 4 oxygens on the right. Problem is, when I added those 4 oxygens, I also added 8 hydrogens. Do you see that I have 8 hydrogens now on the right? So I need to add 8 hydrogens on the left. So I'm just going to rewrite this so that we have more space. But all I'm doing is I'm adding those 8 hydrogens on the left. So now I should double check everything. I can double check. I got 8 hydrogens on the left, 8 hydrogens on the right. I got 1 manganese on the left, 1 on the right, 4 oxygens on the left, 4 oxygens on the right. So I'm good there. Everything is balanced according to mass. So that is step number 3. Step number 4 is balance the charge. So let's make sure our charges for each one match. So if I look up here at our oxidation, on the left, overall, we have a -2 charge. Over here on the right, we have a -2 charge. We have another -2 charge, so we're at a -4 charge. And we have a +2 charge. So overall, -4 plus 2 is -2. So on the right, I have -2. On the left, I have -2. So my charges balance. If it didn't, I would need to add more electrons. But up here, we figured out where the electrons were, so everything should balance if you did this part right. Let's look down here. I got 8 plus, I got 5 minus, 1 minus. So I got -6 plus 8. So I'm at +3 overall. Oh, wait, sorry. 5 plus 1, that's a +6, or -6, sorry. We got 8, so we're at +2 charge on the left, +2 charge on the right. So we are good balancing by mass, by charge of our electrons. The second step, 4B, is balancing the electrons between the half reactions. So if you look up here, this one has 2 electrons on the right. This one has 5 electrons. So we need to make these electrons equal. So what we're going to do is the lowest common denominator is 10. So we're going to multiply this top reaction by 5, right? And we're going to multiply this reaction, bottom reaction, by 2. So I'm going to go ahead and write that out. So when I multiply everything by 5, I get 5 waters plus 5 SO3, 2 minuses, 5 SO4, 2 minuses, 10 electrons, and 10 hydrogens. When I multiply my bottom one, I get 16 hydrogens, 10 electrons, 2 MnO4 minuses, 2 Mn, 2 pluses, and 8 waters. So these are my reactions. These are my half reactions. I have balanced them by mass, I've balanced them by charge, I've balanced them by electrons. So now what we can do is we can take this reaction and this reaction. These are our final half reactions. And I'm going to add them together. So let me first just rewrite them So we have them right next to each other, so we can make it a little bit easier to see. So this is my oxidation reaction. Here's my reduction reaction. I'm just rewriting, okay? We're not doing anything too crazy. Okay, so I have my oxidation and my reduction reaction. I am going to add them together. When I add them together, right, I can cross out common things. So let me look. Do I have any commonalities? Well, over here I have 5 waters, and on the right I have 8 waters. So I could cross out 5 of them, couldn't I? So I can cross out all of these waters, and I can cross out 5 of these ones. So 8 minus 5 is 3, so I should have 3 waters left. What else can I cross out? Well, it looks like I have 16 hydrogens on the left, and I have 10 hydrogens on the right. So I can cross out 10 of those. So I'll cross out all 10 of these, and I'll cross out, I can't cross out all of these hydrogens, but I can cross out 10 of them, right? So I'm left with 6. So I have 6 hydrogens left on the left. What else can I cross out? Do I have anything else? Well, I have my electrons, right? I had 10 electrons on the left. I had 10 electrons on the right. I can cross those out. If I look at everything else, I don't think I have anything else I can cross out. So now I'm going to add them together. I'm going to write everything over here that's on the left together that's left. So I should have 5SO3 2 minus plus, let's see, I still have 6 hydrogens, so 6H plus. And I have 2MnO4 minus. Yield, so that was everything on the left side of these equations. Everything on the right, I have 5SO4 2 plus, right? Oh, sorry, that should be 2 minus, right? Yeah, 2 minus. Sorry, that doesn't make a big difference though. Okay, I have 5SO4 2 minus. Keep going. I have 2Mn2 plus, and I have 3 waters. So this should be my answer. Okay, this was number 6 on balancing. I added them all together. Last step, number 7, check. So make sure we have the same of everything. So sulfur, I got 1 on the left. Actually, I got 5 on the left, right? I got 5 on the right. Oxygen, I have 15 on the left. Oh, and another 8. So what I could do is I could once again, this might make it a little bit easier, is we can check, right? So our sulfur, we said we had 5 on the left. We have 5 on the right. Hydrogen, I'm just going to go down this list. Hydrogen, I have 6 on the left. Let's make sure over here I got 6 on the right. Manganese, I got 2 on the left. I got 2 on the right. Oxygen, I have 15 on the left. Oop, but I also have, looks like 4 times 2, I also have 8 on the left. So overall, I have 23 on the left. Let's make sure on this side I have the same amount. So I got 4 oxygens here times 5. So we're at 20 on the left plus another 3. So I got 23 on the left. So awesome. I have all of them by mass. Now let's make sure our charge. So over here I have a -2, and I have 5 of those. So technically I have a -10.